All right, you guys, in this next example, we have solve tangent squared x plus tangent x minus 2 equals 0 over the interval from 0 to 2 pi. Okay, so we're going to walk ourselves through those same steps we looked at before. So first we need to determine whether or not the equation we've been given is linear or quadratic. Okay, when we look at this problem, we see the second exponent here, all right, which lets us know that our problem is quadratic this time. So first thing I'm going to do, as always, is write our problem. Okay. Now, since we've determined that it's quadratic, okay, that means that the way we go about solving this needs to be in the same fashion that we would solve a quadratic. Okay. So I know this looks a little weird to you guys because it's written as a trig equation, all right? But it's still quadratic. So if you want to replace the tangent x's with just a variable, so let's say I replace it with a squared plus a minus 2 equals 0. This is actually the same form that our equation is in. It's just that I've replaced the trig function with a simple variable a. So if I were to give you guys this equation over here, a squared plus a minus 2 equals 0, how would you go about solving it? So we know that it's a quadratic, so you have a bunch of methods that you could use to solve a quadratic. You could factor it, you could use quadratic formula, all of these methods that you have. So when I'm looking at this equation right now, I see that it's factorable. So it's a trinomial. I'm going to split it up into two factors. I'm going to put a in front of both of them. And then I'm looking for the factors of 2 that give me 1. All right, so that would be 1 and 2. I need a positive 1, so I'm going to put a positive 2 here and a negative 1. All right, so it's completely factored. If I wanted to solve for a, I would set each one of those factors equal to 0 and solve. So I have a minus 1 equals 0, a plus 2 equals 0. I'm going to add 1 to both sides for this one, and I'm going to subtract 2 from both sides from the other one. Okay. Now, in the same manner that we just solved that simple quadratic is the same way that we're going to solve the trig quadratic on the left. Okay. So I'm going to factor it. Tangent x minus 1, tangent x plus 2. I'm going to set each one of those factors equal to 0. So for this first one, I'm going to add 1 to both sides. And then that x is embedded in that trig function. We know the only way to get it out is to use the inverse function. So I have x equals tangent inverse of 1. And I'm going to go ahead and solve the factor that's on the right-hand side. So I'm going to subtract 2 from both sides. That's going to give me tangent x equals negative 2. That x is embedded in that trig function. The only way to get it out is to use the inverse. Negative 2. All right, so remember, when your inverse trig functions are in play, the only way that you can solve for the variables means that you are answering the question, what angle satisfies these conditions? So for this first one here, they want us to know what angle gives us a tangent value of 1. Okay, so I have our unit circle here. Let's move it. All right, so they're interested in where x gives me an inverse tangent value of 1. All right, so let's change our color. All right, so tangent, remember, is the same thing as y over x. And because it's 1, that means that I need an angle whose coordinates are the same so that when I divide them, I get 1. So that's going to be pi over 4. And that's going to be 5 pi over 4. Okay, so those are going to be my two answers. Those are the two angles that have a tangent value of 1. Let's change this so they match. All right, so when I write my answer, okay, remember your answer needs to correspond to the interval that they gave you. So I don't remember. So our interval was given to us in radians, okay? So that means when we go to write our answer, it also needs to be in radians. So when I answer this question, which angles give me a tangent value of 1? Well, x is equal to pi over 4 and 5 pi over 4. All right, so I can go ahead and write that under my problem. X equals pi over 4 and x equals 5 pi over 4. Okay. All right, now we have to do the second problem, or the second part rather, where they were interested in knowing which angles give them a tangent value of -2. All right, so if we go back to our unit circle, all right, let me write the second part. So they're interested in where x equals inverse tangent of -2. Okay, so they're interested in which angles give them a tangent value of -2. Well, that angle isn't on the unit circle. That's not one of our standard angles that we're used to seeing, all right? So the only way we're going to be able to calculate that is if we put it into the calculator, all right? So let me pull up our TI-84, okay? So we're interested in which angles give them a tangent value of -2, and where our answer also needs to be in radians. So on my calculator, I need to make sure that I'm in the right mode. So I'm in the right mode, I'm in radians. All right, so I can get out of there. I'm going to put inverse tangent. So I'm going to hit second. The tangent button will give me inverse tangent. And I'm going to type in -2, close parentheses. And I'm going to press enter. All right. So the answer it gave me was -1.0171, let's say. All right, so the calculator gave me x equals x equals -1.1071. I believe that's what we got. Yep. All right, so when we are looking at our answer, so we can't leave it like that. Even though the calculator gave us that answer, we can't actually use that in our solutions. And let me show you why. So the answer that we got is negative, okay? If you remember back to the interval they gave us for the solutions we can give, the interval that they gave us was positive. It was from 0 to 2 pi, which means whatever angles we give them have to be positive angles and they have to be in radians. So I got an issue because this one is negative, all right? So first, let's kind of determine where this would be, okay? So if the angle that we got from our calculator is -1.1071 in radians, okay? Remember, our unit circle is also labeled in radians, all right? We've got pi over 2, pi, 3 pi over 2, 2 pi. So let me show you something. All right, so our unit circle is labeled in radians. We know that pi, all right, is equivalent to 3.14, okay? Pi over 2 would be half of this, all right? So let's calculate what that is. So if we were to have pi divided by 2, that's 1.57. So if I go back and label this, 1.57. If I want to know what 3 pi over 2 is, let's calculate that really quick. 3 pi divided by 2, 4.71, 4.71, and 2 pi would be 2 times 3.14, which would be 6.28. Okay, so I just labeled my unit circle all the way around in radians, but I converted them to decimals just so that you guys could see where our angle that we found, where it fits. Okay, so our angle is negative. So we know that if we're moving in a negative direction on the unit circle, we are moving clockwise. Okay, so if we're moving clockwise, -1.107, that's somewhere in here. All right, so that's our -1.1071. Now, because our angles only have to be positive, all right, I've got to find where this angle is, but in a positive direction. So do you guys remember when we talked about coterminal angles? Remember, coterminal angles differ by 360 degrees, okay? So if I want to correct this angle that I was given, I can say, well, that's equivalent to -1.1071 plus 2 pi. If I add 2 pi to it, it's going to correct it. It's going to give me its coterminal. All right, so let's figure out what that is in our calculator. All right, so let me just recall what we had. So we had second inverse -2. It gave me that number. I'm going to add 2 pi to it. Let's see. Answer plus 2 pi equals. So I get 5.178. I'm going to round it to the nearest second decimal. So the 6 next to it is going to round it up. So that's going to be my answer in a positive direction. So that's the one that I want. So 5.18. So that gives me x equals 5.18. Okay. Now, even though they haven't told me anything, I know that there's going to be another answer. Okay. The reason I know there's going to be another answer is because the value that we're looking for, the angle, is asking me where is this value? Where's tangent -2? Which angles have a tangent value of -2? I know from when we learned about our unit circle is that tangent is negative in 2 places, in 2 quadrants. Tangent is negative in the second quadrant. Tangent is also negative in the 4th quadrant, okay? When we found 5.18, that's the angle that's in the 4th quadrant. So there must be a matching pair that's in the second, okay? So to find the pair that's in the second, all right, because they are in quadrants that are diagonal from each other, their measures are going to differ by 180 degrees or by pi, since we're in radians. So if I want to find the matching pair, I need to subtract pi from this answer that I just got. So the other one is x equals 5.18 minus pi. So let's go ahead and put that in the calculator. So I'm going to recall the last answer that I had, and I'm going to subtract pi from it. And that gives me 2.03. So there's my other one. So my other answer is x equals 2.03. That would be the matching one in the second quadrant. All right. So my 4 answers for this problem, because I know it's been a minute since we started it, was x equals pi over 4 and 5 pi over 4. Those are the first 2. And my other 2 answers is 5.18 and 2.03. Okay. So those are all 4. So when they ask me to write them, I can just write them all together. X equals pi over 4, 2.03, 5 pi over 4, and 5.18. Those are my 4 answers. Okay, so be careful with that one. I wanted to show you guys one that was a little trickier for answers that weren't strictly off the unit circle. All right, so if you need to, rewind the video back and replay it for yourself. Awesome.